This is the video for 4-7 arithmetic sequences. Before watching this video, print out the handout that goes along with this lesson because you may find it helpful to have it with you while you're watching this video. What is a sequence? A sequence is an ordered list of numbers that forms a pattern. I have here two different examples of two different types of sequences. This is called a geometric sequence, and this is called an arithmetic sequence. Now today we're going to be talking about arithmetic sequences, and the two formulas that we're going to be using today only apply to arithmetic sequences. A term of a sequence is each number in the list. So for example, in my example of 2, 4, 6, 8, 2 is going to be my first term and 8 is my fourth term. And whenever we say the nth term, that is any unknown term number. Again, what is an arithmetic sequence? Those are going to be the sequences we're talking about today, and that is a sequence where the difference between consecutive terms is constant. So for example, in my example of 2, 4, 6, 8, my common difference is 2. And so again, there are two different types of formulas we're going to be using today, and the first is a recursive formula, and that is a function rule that relates each term of a sequence to the term before it. And this is an example of a recursive formula. This is the recursive formula. And so how this is read is a of n equals a of n minus 1 plus your common difference. But what does that mean? It means the value of any desired term equals the value of the term right before the desired term plus your common difference. And an explicit formula is a function rule that relates each term of a sequence to the term number. This is the explicit formula, and this is read as a of n equals a of 1 plus n minus 1 times d. And again, what does this mean? It means the value of any desired term equals the value of the first term plus the term number right before the desired term number times your common difference. So before we start talking about recursive and explicit formulas, the first thing we have to learn how to do is recognize if a sequence is arithmetic or not. Because again, these formulas that we're learning about today only apply to arithmetic sequences. So in the first example, this is arithmetic because the common difference between the terms is 5. I'm adding 5 to each term to get to the next term. But if you look on the next example, it's not arithmetic. There's not a common difference in between the terms. So go ahead and hit pause and work out the on your owns. Identify if the sequence is arithmetic or not, and if it is, state the common difference. So here are your answers, and notice on that last one, that's not arithmetic. It says 2, -2, 2, -2. There's definitely a pattern, and it's actually a geometric sequence because we're multiplying each term by -1 in order to get to the next term. But it's not arithmetic. There's no common difference. So just because there's a pattern does not mean it's arithmetic. There has to be a common difference in order for it to be arithmetic. So now we're going to write recursive formulas. And so this is the recursive formula, and again, what this says is the value of any desired term equals the value of the term right before my desired term plus my common difference. And so what is my common difference in this sequence? 7. So what this recursive formula is communicating is the value of any desired term equals the value of the term right before my desired term plus my common difference of 7. And so what is the sixth term? A of 6 equals 105, or in other words, the value of the sixth term equals 105. Well, how did I get that? The value of my sixth term equals the value of my fifth term plus 7. And that's what this is saying. The value of my sixth term equals the value of my fifth term plus 7. So go ahead and hit pause and write a recursive formula for each one of these examples and state the sixth term of the sequence. And if you need to stop this video and rewind it and watch my example again, please do so. Okay, and so here are your two answers. The value of your sixth term in your first example is 33. A of 6 equals 33. And on the next one, A of 6 equals 83. Well, why? What am I saying? The value of my sixth term equals the value of my fifth term plus my common difference of 6. And here I'm saying the value of my sixth term equals the value of my fifth term plus my common difference of 12. Okay, now we're going to write explicit formulas, and these look a little bit more complicated, but if you understand them, they're really not. So let's go over what an explicit formula is. So here's the explicit formula, and again, what this is saying is the value of any desired term equals the value of my first term plus the term number right before my desired term number times my common difference. So how would I write an explicit formula from this sequence? Well, first of all, my first term is 200 and my common difference is 10. So I'm going to say the value of any desired term equals the value of my first term, which is 200, plus the term number right before my desired term number times my common difference, which is 10. So how would we determine the value of the 12th term? A of 12 equals 310, or in other words, the value of the 12th term equals 310. Well, why? What am I doing? I'm saying A of 12, or the value of the 12th term equals the value of my first term, which is 200, plus 11 times my common difference, which is 10. Why am I picking 11? Because I'm trying to find the value of my 12th term. And so, if n is 12, n minus 1 is 11. Well, let's talk about why. If you understand why, it's not as hard as it looks. What am I doing to determine the 12th term? I'm adding 10 to my first term 11 times. If I want to determine the 12th term, I'm adding my common difference of 10 to my first term, which was 211 times. And that's what this means. I'm taking my first term and I'm adding 10 to it 11 times. Let's think about why. Let's go back up to the sequence. I have 200, 210, 220, 230, and so let's think about 230. 230 is my fourth term. How did I get to my fourth term? I took my first term and I added 10 to it 3 times. And so if I want to figure out my 12th term, I'm going to keep adding 10, 240, 250, 260, 270. I'm going to keep doing that until I hit my 12th term. Well, in doing so, what am I doing? If I want to figure out the 12th term, what I'm doing is I'm adding my common difference to my first term 11 times. And that will give me my 12th term. And so that's what I mean by 11 times 10. I'm adding my common difference to my first term 11 times. And here I just worked it out for you at the top. Again, if I want to find the 12th term, what am I doing? I'm adding 10 to my first term 11 times. And that will give me my 12th term. And that's where this comes from. and that's why it's always your common difference times n minus 1. So go ahead and rewind that and watch that again if you need to, and then do the on your own and write an explicit formula for the given sequence, and then find the 15th term. And here's your answer. A of 15, or the value of the 15th term, is 75.5. Why? Because what am I doing? Well, here's your formula. The value of any desired term equals the value of the first term plus n minus 1 times negative 1.75. First of all, make sure you use parentheses there to communicate multiplication and not subtraction. That's super important. But what am I doing to find the 15th term? If this is 15, and if n is 15, n minus 1 is 14. What am I doing? In order to find the 15th term, I need to subtract. Look at the pattern. I'm going down by 1.75. Each term, I'm going down by 1.75. So in order to get to the 15th term, I need to subtract 1.75 from my first term 14 times. And so finally, now we're going to be writing explicit formulas from recursive formulas and vice versa. And this is pretty simple. It says write an explicit formula from this recursive formula. So here's my explicit formula, and all I'm doing is taking the information found here and putting it into the different formula. I'm taking all the information found from this recursive formula and putting it into my explicit formula. Here's my first term, and here's my common difference, which is communicated here. So go ahead and hit pause and work out that on your own. And here you go. I'm just taking the information found here and putting it into my formula, into my explicit formula. Okay, and now let's do it the other way. I want to write a recursive formula from an explicit formula. So here's my recursive formula, and all I'm doing is grabbing the information from this explicit formula and putting it into my recursive formula. Here's a of 1, and here's my common difference. And so this right here is the recursive formula, and then all you have to do is communicate what the value of the first term is. So go ahead and hit pause and work out the on your own. And here you go. You're just grabbing the information from this formula and putting it into the explicit formula. And so this is just to help you practice memorizing the different formulas, because you do need to memorize them, and you need to know them by name. Okay, so go ahead and watch this video again as you need to when you're doing your homework, and email me if you have any questions.